So good morning all. We'll just continue with where we left. So in the last class we had discussed about the different steps, and among that the last was the transfer of information into manufacturing. So as it is very evident that if the correct information is not transferred into manufacturing, then the manufacturer will produce the part as they want, and ultimately it will lead to scrap and rework. Hence the transfer of information into the manufacturing department has to be carried out very effectively. So for that, transfer of knowledge into manufacturing does not occur sequentially at the end of the process. So basically this we have discussed, like if we take an example of concurrent engineering and sequential engineering, what happens in sequential engineering is that whenever the information is transferred from one department to other, the information is transferred sequentially, or you can say those kind of engineering is transfer of information as across the wall transfer of information, because the information is transferred sequentially, and once at each department if the difficulties arise, then immediately it will be stepped back to the first department itself or the design department, and then the necessary changes will be made, and then the information is made to flow sequentially. So this incurs a lot of time for the product to come out into the market, and also it involves a lot of redesign. But if you consider the concurrent engineering, all the major design changes are done at the initial stage itself. Later there will be no changes that will be incurred in concurrent engineering, because the information will be shared initially to all the departments and all the changes are incurred in the initial phase itself. Hence in concurrent engineering the information is conveyed very easily to the manufacturing department, and that a manufacturing expert should be the designer. Yes, a manufacturing expert must be a designer, because he must have some knowledge of the design. That means you need to extract what is printed or what is conveyed in the drawings by the designer, then only it is suitable for him to do the manufacturing of the part. DFM, design for manufacturing and design for assembly, are integral part of design process and should not be neglected. So I studied about the design for manufacturing, so and also discussed about some problems. So that is, design for manufacturing and design for assembly are very important and should not be neglected. The development of design from early time to soft tools demands the talents of both discipline of engineering. So the conversion or the development of the design from early time to the present soft tools, that is the modeling tools, where you are going to use the computers to model the components, requires a lot of talent and discipline in engineering. Then skills of designs. So you can see the first one is the artistic design role. So as I told, the whatever nowadays the present trend is that whenever you see a component, if it is artistically good or aesthetically good, you directly say that the design of that particular component is very good. But as I told, we had discussed in the last class, it is not true. It is just the aesthetic look, and it has some impact on the design, but it is not complete design. To bring aesthetic excellence to design, so the aesthetic design role is to bring the aesthetic excellence to design, and he needs to be skilled in creation, forms of drawing, and to lesser extent innovation. See, whatever the artistic design is to do, he must be skilled in creation, form of drawing, and to lesser extent innovation. The innovation must be less, because if you do on innovating, then you will not be able to convey your information effectively, particularly for a artistic designer. Then industrial designer role adds practical aesthetics to design, usually in form. Basically what happens in industrial design role is that he adds practical aesthetics to design, usually in the form. So that means external shape, external looks, external appearance is just the role of the industrial designer, and is influenced by the ergonomics and human factor aspect of design. So basically ergonomics, here the important term what you are defining is the ergonomics. So basically the industrial designer plays very importantly the ergonomics. That means what will be the work area, effective movement of the human body when is working on a particular component, how important the workflow is taking. So these all things come under the ergonomics. Then the concept designer. So basically this concept designer is very important because he is the one, this concept designs are the one which will become the final design. So the concept designer plays a very important role and must have all the knowledge of the materials, cost of the materials and parts to be manufactured and the machines that are available, human force, the labors that are available in a particular plant and what capacity the plant must run. So he should have all the knowledge, then only he can build the concept design according to that. So basically depending upon the concept design, the higher authority or the brainstorming session will be done to choose the final design among the conceptual design itself. So hence the conceptual designer plays a very important role in designing the part of the component or in success of the part of the component, success of the part or the component. Next, the product designer. He is less involved with the creativity and form. That is true because already it has been done by the concept designer and he is more over with the cost and manufacturing. So what is production engineer? What he does with that? He is basically in charge of the shop floor. As you know, he is basically in charge of the shop floor. Whatever the design layouts that are come to the production departments, he must make sure that whatever the designs that are conveyed must be effectively manufactured within the time frame. So for that he doesn't have to be more innovative or he must have all the knowledge of the design and all. He must have the knowledge of the shop floor, which all machines are available, which all machine can run a longer duration of time and which all labors are skilled and which all labors are not skilled, to whom the work should be assigned first, to whom the work should be assigned second, and who will be working in the shift wise and who will be working in the regular shift. So these all things will be taken so that the proper allocation of the work to produce the particular part is done by the product engineer. Then the detailer is focused on constructing of drawing and documentation, final definition to design, recording every element of the process of manufacturing. So the detailer, so basically consider two important functions or two important roles over here, the detailer. So what I can say is that whenever the concept design or the design is finalized by the design engineer, what the detailer will do that, he will just detail the drawings in 2D, will just convert the 3D into 2D and label all the dimensions which are required for manufacturing. So that is the first function. So second function will be like the documentation always involves whenever the part comes and part goes out of the industry, he must keep track of that particular outward and inward of the movement of the parts. So he may have implement SAP etc. to document all the parts associated with that particular product and inward movement of the raw materials, the tools, the machines and the outward movement of the final product, inspection tools etc. These all things have to be documented and this is done by the detailer. So then management process versus design process. Management process versus design process versus tools. So as competition increases and customers become demanding, companies are searching different ways for improving quality, as it is true, because nowadays what you can say is that the competition for a particular, if you look at a particular product, you will be having a lot of varieties to choose from if you are a customer. That means there is a lot of competition for that particular product. That means a lot of manufacturers are manufacturing the same product with little variations. So hence, because of which the customer will get a lot of varieties and also he will become very choosy, because of which the demand of the customer is also going to increase. That is the present trend or present scenario. So that extensive use of computer-aided design techniques, computer-aided analysis made design engineers great difficulty to decide which system is best. The extensive use of computer-aided techniques, computer-aided analysis made design engineers great difficult to decide which system is the best. Basically, If you look at, there are a whole lot of systems. Some say that the CATIA is good for the surface modeling and Pro is good for the solid modeling, and some people who are say that some software is very good for sheet metal modeling. Hence, there is a lot of confusion which to buy. So, as a company, if I run a company, I can't buy all the softwares or all the options that are available for me. I can afford only one, but which one to afford? So, there will be always be the confusion. There are three distinct group of changes that can be introduced into processes. So first, the management processes. These are processes affect the way team is managed, such as motivation, resource allocation, and monitoring. So basically, these are processes affect the way team is managed, such as motivation, resource allocation, and monitoring. Second, essentially, they do not do anything to change the way in which design is done. Essentially, they do not do anything to change the way in which the design is done. Third, the outcome of the design depends on the team that converts ideas into final product. Basically, the outcome of the design depends on the team that converts ideas into final product. It is true. If they do not convert that, because there are a lot of people who always give ideas, but if we ask them to do, obviously they will not do. Hence, if the ideas are not converted into product, then what's the use of the ideas? It is a waste. Hence, the outcome of the design always depends upon the team that converts ideas into product or final product. The design process. The next, the changes under this category are changes that tell the designer to do job in different way. Obviously, if a person is taking 100 iterations to do a final design for a component, if a other designer taking only 20 different steps to arrive at the final design for a particular component, then obviously which one you will choose? Obviously you will choose a designer who is going to give you the final design in 20 steps rather than the designer who will give you the final design in 100 steps. So then he must be able to make use of innovations, what is happening in technology, and also he must be innovative with respect to his idea generations and with respect to the way he works. Then only he may give an alternate solution which will be time reducing and also which will reduce the cost. The designer and team should change the way in which they do business in order to get closer to higher quality product. As I say that the designer and his team must change their way. That means they must be responsible for each of their activities. So they must not say that whenever they do the design and detailing, when they pass those design and detailing process to other department, then they should not think that the job is over. Their job is not over until the final product is delivered to the customer and customer is satisfied by the usage of that product or by the function of the product that the product is giving to the customer. So that means the designer must take the whole responsibility of the product and must commit himself in the success of the product. Tools and methods. If company changes from manual to CAD, that is important. If company changes from manual to CAD, the rate and quality of drawing production is reduced first. Tools and methods can be used as part of overall program to support improvement in quality, etc. So basically, if you are doing manual drawings, then it will take a whole lot of time to produce a single drawing. But similarly, if you do that same part drawing by using the CAD tools on the computers, then it will consume very less time to give the final outcome. Hence, obviously, if you shift from traditional to CAD tools, then there will be a lot of saving of time. Tools and methods can be used as part and overall program to support the improvements in the quality. It will also help to enhance the quality of the product. Enablers for design quality. Design quality can be achieved if following enablers are established at onset of design exercises. So just look at, So if we look at the inputs, the enablers must be like goals. The goals must be input, the plans must be the input, the marketing must be the input, the business must be input, the technology must be input, and our architecture must be the input. What we can see in the staff, the number of the staff, the capacity of the staff, the training of the staff is required, availability of the staff, and then skill mix. So there must not be only a particular skill set of people that must be available. The staff which we have must be a mix of the every skill, so that whenever a need arises, there is always a certain group of people who will be doing that particular job. Because we know that when manufacturing a certain product, there are way lot of problems or way lot of challenges that will come across the management. Hence, so to meet those overall challenges that is going to arrive when designing a product, we require all skill set. That means people who must be expert in each department must be available, so that whenever the problem arises any department, there will always be a go-to person, so that he will be addressing that particular problem associated with the particular department. Hence, there must be a mix of all the skills that must be available when you are considering with the staff that are working in your particular industry. Then modeling, analysis and capability. The tools basically we require over are the software tools. The systems must be in high configuration. The skills again work of the worker who will be working on this tools must be high, and the technology. The technology must be a latest one, and obviously to incorporate all those things there must be a knowledge base for that. Certain like manuals, etc. must be available. The processes. The process in that the disciplines must be there, the training, the process must be there, and the tools must to support the process must be there, and the commitment for the particular process must be always there. The workflow of the process must be smooth, and the review or audit capability, you can say the management process commitment checklist must always be done to carry out the support the audit. And this all are the key inputs for the design quality of the particular product, which if you take the inputs and the design quality, the commitment from the manager is required, which requires the recruitment of the proper personnel so as to achieve your goals, and train the recruited staff members in the way you want to work, and to always support the staff members whenever they require, so that they should have faith in our organization and should provide fund. Whenever you achieve huge profit, a small bunch of profit can be shared with the employees, so that the morale is always held high. And you should organize the employees very systematically, and also not only to organize but also you should manage them emotionally as well as financially. And environment, and you should build an environment where the worker must feel themselves safe to work on and should get motivated to work in that particular environment. That means he should start liking that particular environment to work. Then the empowerment. So there should not be always an empowerment. Design inputs. So goals are defined by marketers. The design inputs. Goals are defined by the marketers. The basic technology set must be clearly defined to design team as well as architecture. So these are the design inputs. Staff. The human resource in terms of total power and expertise to tackle job. Right people with right skills and training is required. The right people with the right skills of training is required. The team must have correct balance of skills and must be available to work as a team. The team must have correct balance of skills and must be available to work as a team. Modeling and analysis capability. The necessary academic expertise and tools to support level of technology must be required. That means the necessary academic expertise and tools to support level of technology. So basically necessary academic expertise, in order to build the necessary academic expertise, the industries nowadays are tying with the academic institution, so that the academic expertise in that particular industry is always maintained, so that the latest research, what is happening in the area, is always must be known to the industries, and the tools to support the level of technology. That means if the technology changes, they must have the particular tool to support the change in technology. That must be always be incorporated in particular industries, and the type of analysis is defined, and then establish right tools to implement the process. So if you are doing certain work, there must be proper tools to support that work, so that the order for that particular work is executed well within the time frame specified by the customer. Then the processes, so where you need to control all the processes. So basically it involves the proper process planning, proper allocation of the work centers for the particular worker and for the particular part running, and proper cycle time should be maintained, and proper technology or safety precautions must be associated with that particular machine, and cleaning of the clean shop floors must be maintained with all the latest technology for ease of movement of the workloads must always be provided. Review and audit capability. The ability to assess the progress of the design. Throughout the process of the program, the team and its management must have capability to monitor progress in order to take right decision. Throughout the progress of the program, the team and its management must have capability to monitor progress in order to take the right decisions. Management commitment. This is important parameter amongst all. The management commitment is the important parameter amongst all. Without commitment from management, program is likely to suffer failure at earliest. Without commitment from management, program is likely to suffer failure at earliest. That is true. Management has ability to recruit and train staff. So management has the ability to recruit and train staff. So the management must always see to it that the right staff is selected, who is willing to learn or improve his skills in order to suit the outcomes of the particular industry. Then only the industry is going to survive. If you keep on hiring the people without any knowledge, then he is not going to deliver the expected work to the industry, and obviously it will lead to the cascading effect. And provide funding and commitment to capital expenditure. Always provide funding and commitment to capital expenditure. So if you don't provide funding, then you will not be able to climb the ladder. So if you are not able to climb the ladder, then you will stay at the level where you are. After 20 years, you will be at the same level itself. So if you want to climb the ladder by the change in year and the change in times, you must always provide funding and commitment to capital expenditure. Provide empowerment of the team, individuals in team to organize and manage the day-to-day program activities. Structure of design process. So basically the structure of the design process involves to define the So here, structure of the design process, defining the requirements of the customers. So basically the structure of the design process involves define the requirements of the customers. The customer requirements must become the specifications of that particular product. So the customer requirement is very important. And then generate ideas by innovation. So innovation is very important in any particular product design. Because of the innovation, only the new ideas will come, and that will result into a new design. Hence, the generate ideas by innovation is very much important. Understand the function. So basically what we are designing for. By the design, whether the function of the part is getting achieved or not, that we should keep in mind. If by the design the function of the product is not getting served, then the design is a utter waste. Hence, we should always understand the function of the part before going into design of the particular part or any product. Translate design into drawings or design life. We call it as a design life. That we should translate the design into drawings, then only we can give life to that particular design. Because if you are not converting the design into drawings, then then the design will not get manufactured. So the design will get manufactured or come into reality only once the design is converted into drawings. Hence we call it as a design life. The transfer of information into manufacturing, as I told, this is very important information. So whatever the drawings, 2D drawings, what you are implementing to the product engineering or production department must be true in all the senses and must be clearly specify what we want from that particular product from the manufacturing department. So that must be very clear. The above 5 elements translate into a structure that can be thought as, so this above 5 elements translate into a structure that can be thought as translation of customer requirement into design criteria. So that is true. That is one and second point. Understanding how design functions, that is the third point. Converting design into hardware, building and testing, that is the fourth and fifth point. Then we have discussed about translating customer requirements into design criteria. Blend known requirements of customers with engineering approach to meet needs. One of the product is chosen in broad terms, that is customer who needs to tell what exactly lies in the product which gives satisfaction. The Kano model is studied. The designer must be aware of 3 separate areas relating to customer requirements. Basic customer requirements are their expected requirements which are assumed to be available by the customer. So these are the basic customer requirements. These are the expected requirements which are assumed to be available by the customer. That means they are always using that particular product and they are well adjusted with that product. That means, so that is the basic requirement that must be assumed. That means if you look at a pen, the basic requirement of the pen, what we do with the customer required from that particular pen is it must write. So this is an example of the basic requirement which are assumed to be available by the customer. Performance related customer requirements. Sorry. Performance related customer requirements. So basically, again we'll take an example of pen only over here. If as a customer, if I want to buy a pen, what I desire from a pen is that it must write on a paper. That is the basic requirement. If I classify with respect to performance related requirement, then I should think that how long the pen is going to write without any breakage or without any breakdown. So that defines the performance related customer requirements. The design process. You can say that architectural process. It is a highly complex system and have many elements that are linked together to build finally a product. The arrangement of these elements both in geometric form or in spatial form comprise architecture, that is basically the design. The architectural development process flows 5 broad phases: definition, concept generation and concept reduction, concept evolution, output. Architectural development process. So you can see on the y-axis that growth in the number of ideas is given, and on the x-axis there are various process categories that are given, that is the definition, development, evaluation and output. In definition, you look at the outputs and the bounded definitions, which are outputs established, architecture, core lean form, development through scope desired, pieces support group identified and categorized, assumptions established, competitive trend marketing strategy established, and in concept generation, franchise development, and in that franchise identified concepts, brainstormed, concepts and functions integrated, architectural study, and papers identified and written. So these all things, the activities come under design development and also in the concept generation. Then the concept production, that means choosing the final design out of the conceptual designs. In that we say it is an evaluation process. In that functional requirement must be considered, reviewed and satisfied, product specification reviewed and satisfied, concept retrievation and concepts elimination is taking place over here, and candidate selection were taking place in that particular concept production, or you can say the evaluation process. So the next is the output, where you can club 2 points, that is the concept evaluation and outputs. So when you are chosen 2 concept design, among which you need to choose the final and what is the evolution that you are going to take place for that particular concept. So that means evolution methods that must be selected over here, and business and schooling risk assess, all association is considered. Here in outputs we are concluding about the conclusions reached from that particular concept design, and questions identified, if any, then that must be suitably addressed, and recommendations if made have to incorporate and make the final modification. So PUG method. So basically, if you have the criteria and ideas, for the ideas, see that this goes on changing for any particular product, is just an example. And if you look at the criteria, standard for all the things. For A, it is all the standard, that they are the medium level standards, and for B, first standard is added, and for the second standard, for the B component, it is reduced, and for the third, it is kept as it is. And if you look at the C component, and the first standard for the C component is reduced, and the second standard for the C component is increased, and the third standard for C component is again increased. That means if you look at a particular concept design, you consider concept design A, concept design B, and concept design C, and what are the criteria that will be changing with respect to the each concept design are highlighted over here. So if you are using the standard parts for the first conceptual design, if it consists of 3 parts, the product consists of the 3 parts, and the first, second, third parts are all standard that might be used for the first conceptual design, and the second conceptual design, you can say the standard of the first part is increased, and the standard of the second part is decreased, and the standard of third part is as maintained with respect to the first part itself. And if you look at the third product, the standard of the first part is reduced, and the standard of the second part is increased, and the standard of the third part is also increased. So again, if you look at the ideas in the second sheet also, like A, B, C, D, E, if these are idea generated, that is, you can say the conceptual design itself. And the criteria, if you look at over here, the criteria are noise reduction, cost, time to implement, and performance. So if you look at over here, for the third component, it is selected standards, and all the components are standard. If you look at the first, the noise reduction, that particular concept design is giving more than standard, so we are written plus. And for cost, it is having less cost, hence it is written as positive. For time to implement, it requires more time to implement, hence we are written for that negative. And performance, obviously it is going to perform better than C, hence it has written plus. And if you look at the B, respect to noise reduction with respect to the C component, it is good, hence it is written positive or by a plus sign. And for the cost, it is less cost compared to the C, hence it is written as plus over here. And time to implement is also very less for the second product concept to implement, hence it is written plus over here. And the performance wise also it is plus compared to the third product or third conceptual design. And if you look at the fourth conceptual design is always compared with the third, because third we are already selected, and with respect to that third only we are comparing A, B as well as D and E. If we compare D with C with respect to all the criteria, for the noise reduction it is again standard. That means it is same with respect to the third component. And the cost, if we look at the cost of the fourth component and compare with the third component, it is less cost, hence it is written as a positive. And time to implement, the time to implement with respect for the third component, if you are considering for the fourth, is negative, less is more, hence it is written as negative. And performance wise it is also quite less compared to C, hence it is written as negative. And if you compare the fifth, that is the E component conceptual design with the C component conceptual design with respect to the criteria like noise reduction, it is same, hence it is written as same. As cost, it is more costlier than C, hence it is written as negative, that is a negative point. And then time implement, also it requires more time to implement, hence it is written as negative. And performance wise also it is same, hence it is written as S. So if you look at all these things, what I can say is that here look at the criteria wise. Here the criteria is mentioned, and these are the standard, and these are the plus, and these are the negatives. For each of the component you write the same. Here it is 0, here the same is 1 with respect to the third, and all the here are 4 are the standard only. So it is 4 standard, and D 1 is standard or same we can say, and for E 2 are same. And plus points, for A it is 3, and for B it is 3, and for C it is 0, and for D it is 1, and for E it is 0. And for A the negative points are 1, for B it is 0, and C it is 0, D is 2, and for E is again 2. Now how are you going to select the design or the part conceptual design among all these suitable options? So these are the table or the criteria that we must choose, and after choosing you need to elaborate by using a table that we have represented, and how to arrive at a conclusion. That means which one you need to choose among all these 5 available options. So here if you look at the negative points of all the 5, B and C does not have any negative points. B and C does not have any negative points. But if you look at A, it has 1 negative point, hence we are not considering this. If you look at D, it has 1 negative point, we are not considering this. If you look at E, it has 2 negative points, hence we are not considering this. But here B and C does not have any negative points itself. So we need to choose among B and C, but again which one to choose? If you look at the same parts of the standard parts, B has got 1 and C has got all the 4 standard parts. But if you look at the plus points, B has 3 plus points, whereas C has 0 plus points. Hence, with respect to compare to B and C, I feel that the B conceptual design is very good with respect to its available conceptual design. Hence, I am going to choose in this example the concept design of B. Hence, it is selection here marked as a star. So that means this is chosen among all the available options. So the combinate method, this method is divided into 7 steps. There is one more method of design, selecting a conceptual design. So that is the combinate method. This method has basically 7 steps. The first is that definition of selection criteria. The decision maker selects all criteria by which choice is made. The decision makers select all criteria by which choice is made. The cost, reliability, size are most important, but also others are related to specific preferences. The cost, reliability, size are most important, but also others are related to specific preferences. Weightage of selection criteria. Criteria defined to make choice does not have importance in customer's mind. And decisions are made such that which criteria are important to customers. So weightage of selection criteria. The criteria are defined to make choice does not have importance in customer's mind. That is true. And decisions are made such that which criteria are more important to customers. So we are discussed in the earlier slide. There are 5 criteria, but in that 5 criteria, the 2 criteria are very important for the customer. So if the customer has the 2 criteria, then he's obviously going to choose the 2 criteria. So that means I'll just take an example further for this by taking 2 cars. If I say 2 cars of sedan segment like Honda Amaze and Maruti Suzuki Swift Desire. So there are 2 customers. So one customer requirement is like he wants a brand and he wants more power. And other customer requirement is that he wants more efficiency and he wants more service stations and he must be comfortable with that and less maintenance cost. These are some of the customer requirements of customer B. And customer A requirements are that he wants the brand name and he wants a high power in these 2 cars. So as a Honda Amaze delivers a brand as well as more power in that particular segment, then the customer A will choose that because those 2 requirements are the importance for him. But if you look at the customer B, his prime requirements are it must be less in cost, it must be a sedan, it must have less cost, even though he can sacrifice on the power, it must have the greater mileage, and serviceability must be very good and in low maintenance. That means the car must have the low maintenance cost. So with respect to his requirements, then Maruti Swift Desire is very good. So that is what is that decisions are made such that which criteria are important to the customers. Development of utility curves. Here each of the criteria is given value such that customer should be 100% happy. That is true. A curve is drawn between 0 to 100% called the utility curve. The curve is drawn from 0 to 100%. Then assignment of points to each alternative. Points are assigned using utility curve to each criteria for each alternative, and then assignment of points to each alternative. The weightage is given by multiplying points with weighing factor. Making the choice is made by looking for highest score, that is true, and applying the test. So here the Combinate Method. So it is drawn from 0 to 100%. For the cost and power, it is from 2 to 100%, and failure rate, it is from linearly exposing from 4 to 100%. So again here also you can see that there are requirement points for the cost A, B, C, which is A is 100%, B is 80%, C is 70%. After a cost of 16,000 to 17,000, B and C are located, and A is located well within the range of 15,000. And if you look at the length, the C point is at 100%, A's point as a 90%, which is almost close to 4,500 length, and which is in terms of mm. And for B, it is always close to length of 4,700 mm, and the percentage is 60%. And if you look at the range, so the A point is like around 500 miles and it is 65%, and for B it is close to 600 miles, which is again 68% approximately, and C point is like 100%, it is more than 7,200 miles. So then features. Here also they are discussed about the car itself, we are discussing about the car. Failures, the car A, car B, car C. The cost is for the failure cost for the car A, car B, car C are given. For car A it is 15,182 approximately, for car B it is 16,300, for car C it is 60,750. And for engine capacity CC it is 1,991 for A, 2,600 for B, and 1,800 for C. And overall length in mm, what I discussed in the chart before slide, previous slide, it is 4,385 mm for the first car, that is A, and 4,640 mm for the second car, that is B, and 4,227 mm for the car C, that is the third option. Overall width also they have mentioned it is 1645 mm for A, 1732 mm for B, 1670 mm for car C. And fuel capacity in liters they have mentioned that is 62 liter, the car is having a fuel tank capacity of 62 liters, and car B a fuel tank capacity of 75 liters, and car C is having a fuel tank capacity of 80 liters, and 0 to 50 miles per hour in time. So it requires for car A 10.6 seconds to reach from 0 to 60 miles per hour, and for B it requires 9.8, and for C it requires 10.2. Fuel consumption at 56 miles per hour, that means we are taking an average speed, and what might be the fuel consumption for each of the car. For A it is 8.5 liters, and for car B it is 8.1 liters, and for car C it is 9.1 liters. The range of miles are also mentioned, like 527 miles for car A, 605 miles for car B, and 730 miles for car C. If you run at an average consumption of fuel at 8.5 miles per liter. That this combined method is always given like this. For car A, car B, they are mentioned on the columns, and on the row side criteria we need to mention, that is the cost, length and range. So weighting is given as 0.5 cost, and for length it is 0.3, and for range it is 0.2, and scores we are associated like 98, 90 and 67. So weighted score for car A will come as 49 for cost, 29 for length, 13.4 for range, and the overall score will come like 80, 60 and 68 for cost, length and range. And for car B the weighted score will come like 40 for the cost, 18 for the length, and for the range it is 30.6. If you look at the overall score, it will come as 70, 100, 100. And the weighted score for C, it will come as the overall score will come as 70, 100, 100, and for the cost it is 35, for the length it is 30, and for the range it is 20. So hence if you add up all the values, the total will be like, for car A it is 89.4, for car B it is 71.6, and for car C it is 85. So if you look at all the car segments, which one you prefer? According to this combined method, the car A is preferred because it has consumed more points than car B and car C. Brainstorming. Next is the brainstorming. A team formed to bring out the best in innovative thinking, called as brainstorming. Here, strong discipline has to be followed to work effectively. Rules are followed before session begins. Some of the rules that we need to follow for the brainstorming are: there must be no criticism, basically. Should not criticize one for his ideas. Hence, then only he'll say something. If you start criticizing, then he'll always keep quiet, then there will be no meaning for the brainstorming session. And there must not be any evaluation for that. And one at a time should come out, because once you start speaking, you can't go on speaking, because all the things cannot be recorded and all the things cannot be evaluated also. Hence, you need to speak one ideas at a time, and then only it will be an effective session. And basically, we always tend to forget the things what we said after a certain duration of time. If we have a habit of writing everything on the wall board, that will be good practice for the brainstorming session. And record all the words especially, and work quickly. I need to act very quickly for this particular session. So reliability growth, this I have discussed while discussing with the reliability unit. That is, it is checked by measuring failure rates and can be measured in terms of failures per 10⁶ cycles of product's operation. And the number of failure for the first prototype until the launch, we can say that for the first prototype, always see that there will be design changes, hence there will be a lot of failure. If you look at the failure of all the three, like technological failures, design failure and manufacturing failures, they all keep on reducing from the first prototype to the launch, because as you come to launch the product, it is almost a perfect product. But once we were in the trying out the first prototype, it is nowhere a perfect product, and lot of changes and will occur because we are not into perfect design. Hence, there will be a lot of failures in the early prototype testing. So hence, if you look at the failure rates with respect to technology, design and manufacturing, the technology failures will be more, and the design failures will be less than the technology failures, but will be more than the manufacturing failures. And if you look at the manufacturing failures, the failures will be there, but it is slightly less than the technology failures and the design failures. So this how it is can look at over here. The failure rate with respect to concept phase, prototype and launch. So if you look at the failure rate in the conceptual phase, the technology readiness growth is more, hence the failure rate with respect to technology is more at the concept phase, because everything will be done in the software. And then design quality growth is also more, because when it changes you need to change the design. And then the prototype also, it will be linear but it will be there. And then once you look at the launch, the technological limitations will be less, hence the failure rate with respect to technology will be less. And also at the launch you have taken all the care with respect to the design, hence the design faults will be very less when it is launched. But there will be certain, sometimes there will be a design changes, design faults will also have also been seen. Technology readiness. Maurice F. Holmes defined 5 criteria for technology readiness. That is, one is the critical parameters. So here parameters have a primary effect on function of system and also on the failure modes. Nominal values are specified using analytical or empirical methods. The failure modes basically involve the subsystems and system level failures, which are identified by selected technologies, and by doing so it helps in improving the reliability of the product. Latitude. Knowledge of latitude will be valuable for optimization process, reducing cost and good manufacturability. The manufacturability must also be taken care, and demonstration of hardware is also needs to be done. The process of design. The development of design of product is done such that it should answer all following questions. It should answer the proposed design is feasible in its operation and must be function. Whether it is feasible, the proposed design in its operation and function, it has to answer. Whether the systems can be integrated, again it is a question that needs to be answered. Engineering problems associated with proposed design. Whether there are any engineering problems that are associated with the proposed design, we need to answer that question also. And the manufacturing reliability and performance problems associated with the proposed design, these things needs to be answered very quickly, and hence in order to answer these questions, hardware and design iterations are required. So design for manufacturing we have discussed. The same thing bit is introduced in this unit also. So we'll stop here and we'll continue it in the next class.